Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on OSPF. Let's start our part 7.
Okay, after covered all the different type of the network, so right now we're going to cover on the optimizing the OSPF neighbor relationship. So in this requirement over here, they will say that set the interval of the FR network on the hello packet to 10 seconds and the 40 seconds when the neighbor relationship is invalid. So over here we need to know this one is configured on the R2, R3, R4 is under the FR network, and also configure the DR and send the hello packet immediate after the DR is changed. So in this situation, what we need to do, we need to change on R2, R3 and R4, change the hello timer and the port timer, as well as to enable the DR hello packet. We call this as a, let's check on the configuration, we call this as a OSPF smart discovered. So it means that when your DR change, they will immediately send the hello. So this is what we're going to configure. First we change the hello on the OSPF and the port timer. So we need to know the default. For MBMA, the default timer will be 30 seconds, date timer 120, and the port timer will be 120. So we're going to change to 10, 40 and 40. So let me show you how we're going to configure it on the simulator. So I will going to do it on the R3 to configure the timer. So we configure on the serial interface OSPF timer hello to 10 seconds and OSPF timer, the port timer will be sorry, my mistake, will be 40 seconds. So I have a 10 second, 40 second, and also don't forget to remember the smart discovered. Okay, so I configure an R4. So I go to interface S100 OSPF timer hello 10 seconds OSPF timer port timer 40 seconds and OSPF smart discovered. And the last one, configure an R2 on the interface S100 OSPF timer hello 10 seconds OSPF timer, the port timer 40 seconds and OSPF the smart discover enable. So in this case, let's say when I change the OSPF interface S100, you see that right now my hello is 10 seconds, that timer and the port timer. So this one is all regarding on the neighbor relationship. So this one is how we're going to do the changes on the hello and also all the other timer and to enable the smart discovery. So next we're going to look at on the OSPF attribute, the route attribute. So over here the requirement here is on the R2 and R5 each access each other through the R2, R3, R5. The configuration must be performed on R4. And then when route are imported from the network 10.0x024 to the OSPF AS, the route type is type 1 and the cost have to be 20. So it means that between R2 to R5, I need to go in through this way and I configured on R4. And whatever I import into the OSPF, I need to make sure they belong to a type 1 and the cost of 20. Alright, so it means that I need to go to two routers, R1 and R4 to configure on this route attribute. Let's have a look. This is how they do. They just do the import route direct, make the cost as 20 and make it as a type 1, because by default, as we know, the type will be type 2. And on the R4, we need to change the cost on the 2 interface to cost 20 and the cost of 2000. Alright, right now let me show you that how we're going to configure it. So based on this diagram, we're going to configure it on, let's check on R2. And on R2, when display IP route protocol OSPF, you will see that for us to go to 56, 172.172.10.20.30, they have two paths. They either go to router 4 or router 4, router 3 or router 4. Right now the requirement they only allow to go to router 3, and we need to do the changes on router 4. So over here I will configure on the G00. I change the OSPF cost of 20, let's say, and go to the interface S100. I change the OSPF cost to a bit higher, maybe 100. Alright, after the changes have been done, let's check on R2. Display OSPF route. Again, right now you see that all the route they prefer 1.3 instead of loop balancing, because they have a different cost. They will select the shortest path to go to the destination. And this is for the first question. Second question, I said that, well, I do the import route on R1, I need to make sure that the import route is a cost of 20 and there's a type 1. Let's have a look. Let's have a look on R2. For 10, right now, the cost is 1111, because this one is a type 2. So right now for R1, I need to change the configuration. In the OSPF, when I do the import route direct, I need to make the cost as 20 and change the type to type 1. Then you will see they have different result. Then I display again, you see that right now, instead of 1, right now it become 68. 68 cost to 10, 0, 0, 1, 0, 2, 0, and 3, 0. And this is the how we're going to configure use the route attribute. So we change the cost, the type, and the cost of the OSPF route. Next is controlling all the OSPF routing information. So in this situation, router A, company A need to control some of the route information and have some of the requirement here. R6 does not accept route from the network 172.16x024. The configuration must be performed on R5, and the OSPF AS want to accept route only the network 10.0x0, and the configuration must be configured on the R1. Use the least number of the configuration is recommended. So let's have a look. So over here right now, R6, this route you're not able to go to R6. I need to fill it, but I only can configure on R5. And when R1 import route, I want to the OSPF route AS want to only accept certain route, but not all the full route. Over here is not clear. You can see the question is not clear when compared to the result. The result over here, you will see that right now on the ACL number fielded 2999, they're using 10.0.0.0.0.254.255. What it means over here, it means that they will only allow the 10.0.0.0 and the 10.0.20 go into the OSPF route. And R5, they're going to filter all the route. They filtered the 172.16.0.0.22 filtered to not to go to area 3. So R6 will not able to receive, because I mentioned that I'm denying the 172.16.0.0, but I still permit the rest. So over here, let me show you that how we configure this on the EN SP. So first, I will do it on R5 first to filter the route not able to go to R6. But before that, let's check on R6. Can R6 receive 172 route when display IP routing table, protocol OSPF? You see that 172 I receive, but right now I need to filter all the address. So I need to do it only on R5. On R5, first I define the IP prefix list. IP prefix 10 in text 10 ID9 172.16.00.22 greater equal 24 less equal 24, and I need to allow the rest 10 in text 20 permit 0 less equal 32. So after this, I need to go into the OSPF and do a filter policy IP prefix 10 import. So in this case, after I perform this IP prefix import, R6 should not receive any information from 172 anymore, even though I check protocol OSPF. You cannot see the 172 anymore. And from R1, I need to filter only the even number. Even number, the 10000 and the 10020 are imported into the OSPF. So in this case, I need to configure a ACL. So I just perform a normal ACL 2000. Rules permit a source 10000 0.0.254.255. And I go into the OSPF. I do the filtered, is a filter policy. The filter policy ACL 2000. So over here they only allow using the on this when perform ACL is a name. So in our case over here I just use a number. I will just put as a filtered policy 2000 and export. So in this case, when I go back to R2, you see that the difference display IP routing protocol, routing table protocol OSPF. You see that right now is only 10.00, 10.020 are allowed. Compared to previous, I have 4. Right now I filtered only up to only 2 only. So this one as in how we perform the routing information, how to control the route, how we're going to filter the route from the external or from the network command. This is on the import route and this is from the network command. Next, let's look at it. The next one, you're going to perform the configurations on the NSSA areas. So you see that area 1 does not want to receive the type 5 LSA for other areas, and R1 accessing external network excluding the 10.0x0.24 through the R2. So over here they have 2 requirements. So first I want to say that R1 area 1 do not want to receive type 5, but the rest they still can access the 10.0x0 through the R2 but not R1. So means that this one is a ABR. The rest still can go in through R2 to access the 10 network segment, but it's only the 10.00 and the 10.020 because the 10.010 and 10.030 are filtered by the ACL. So what we're going to do over here on this example, we're going to configure R1, R2 using the NSSA. So let's check on the configuration. On the configuration, you see that over here it's just very simple. On R2, R1, area 1 to configure the NSSA command and SSA command. So just very straightforward. Let's just do it now. So just going to R1 OSPF area 1 and SSA, you see that the neighbor will be down. And going to R2, do the same thing, OSPF area 1 and SSA. So wait for a while, wait for the neighbor coming back. So while waiting, okay, so right now it's under the full state. Let me check on R1. When I display IP routing table on R1, protocol OSPF, and this is all the route that I receive. So in this case, do you think that R6 they still can access to 10.0.0.0? So when I check display IP routing table protocol OSPF again, I still able to go to the 10.0.0.0 and 10.0.2.0 because this one is a non-so stubby areas. Okay, this one is just very straightforward for the NSSA. Then the next, so let's just check on the next one, is improving the security of the OSPF network. So what they mentioned over here, perform the area authentication for the area 0. The authentication mode have to be MD5 and the password as a Huawei. So area 0 is here. So it means that R2, R3 and R4 need to configure the area authentication. But don't forget, you have defined the virtual link between R3 and R5 and R4 and R5. It means that R5 is also part of the area 0. So you still need to go to R5 to configure your authentication as well. If not, your virtual link will be failed. So how to configure the authentication using MD5 and the password as a Huawei? Let's have a look on the solutions. So it's very simple. Going to the area 0, authentication mode as MD5 and the cipher, and this is your password. Just do it on the R2, R3, R4 and R5 to make it happen. Alright, so let me do it over here. So I configure on R2. On R2, I can go to the area 0, authentication mode MD5 1 cipher Huawei. This is a requirement. R3 as well, OSPF area 0, authentication mode MD5 1 cipher Huawei. R4 OSPF area 0, authentication mode MD5 1 cipher Huawei. And the last one, let's check display OSPF virtual link. So right now it's a full state. If let's say R5 is not doing any things, the virtual link will be failed. So over here you need to make sure that the area 0 virtual link is belong to area 0, and you need to configure the authentication as well. You can see that right now the neighbor status become the down state. When I display the OSPF V-link again, you will see that I'm under the down state. Later on the 4444 you go to the down state as well. You see that it's going to the down state. These two you going to the down state. So what to do? Very simple. OSPF area 0 authentication MD5 1 cipher Huawei. You need to configure as a area authentication on the area 0. So now when I display the OSPF V-link again, they're back to a full state and also full state. This is on the security of the OSPF network. So that's all that what we're going to cover on the configuration command. Next, we're going to look at the OSPF troubleshooting.
Thanks for watching. Please do not forget to subscribe to our channel.